question about a lot of twos.
2, 3, 4.
The other ones I'm seeing majority 5. So we'll do 2 and 5 today. So we are solving for v. We have to get v by itself. We have to first get rid of 2 by multiplying it to the other side. So we have 2k equals mv squared. Then we could get rid of m by dividing on both sides. And then to get v by itself, we would take the square root of both sides. So that the square root of 2k all over m, equals v. That was really good. My apologies. Questions on that one? Okay, and then number 5. The x and y intercepts, there's one x-intercept and one y-intercept. Both are the same. I did print perfect on a different color so that we hopefully stop losing them, but we'll see. You have different type of notes today. You may need a ruler, so if you would like a ruler, you can go grab that. You have a set of colored pencils. You're not using all of them, and we're only using specific colors for the first part. So on the first page, while we're getting rulers and getting the colored pencils out, of the colored pencils that put on your desk, or if you have your own ones to use those, you can use those. You need red, brown, and green.
That's the worst one. Why don't you clear one? Because it looks like
Okay, so I'm going to explain the directions that I want you to do them, then we'll come back and talk about them, and it'll be a lot of back and forth. So on this, there are 2 pieces of information. You're talking, you're not listening. There's a box that says given lines and their points. You do not need to do anything with that. That is the given points and lines. The points that are listed under red, brown, and green, you need to plot these 2 points and then find the slope and keep plotting points. Make a line, extend it all the way through your graph. So plot these 2 points, count the slope, and then keep going all the way with your red color pencil. Then do the same thing with brown and do the same thing with green. You guys, because there's only so many colored pencils unless you have your own. One person may want to do red while someone does brown while someone does green. Okay. Graph those points, find the slope, keep graphing the slope points so that you can fill up the graph with those points. I'll give you a few minutes to graph those and then we'll come back and I'll show you need to be finishing at this point. I'm going to show you what the graphs should look like. So I have different points on here. The highlighted ones were already there. And I know it's also a little more easy. your green line should look something like this. If you don't have multiple points, you skipped a step, you only drew your 2 points, you're supposed to count your slope and keep making points. Your red line should look something like this. And then your brown line should look something like this. If you don't have those graphs, get those graphs in the next minute. And then some of you started the next page. So we were given the equations of A, B, and C. Then we had to write the equations of the red line, the brown line, and the green line. If you kept doing all of your slope points, you would have ended up you could have found your slope and then looked at where does it cross the y-axis to get your equations. You could have used this, did the slope algebraically, and then did what we have been doing to find the equation. It doesn't matter. Either way, you should have gotten, I'll write them, and then we'll come back. So if you didn't get this far, that's fine, just write these down. The equation of the red line, the slope of this is 2/3. The y-intercept of the red is at 4. So your equation would be y equals 2/3 x plus 4. The brown line is going down 2 to the right, 1, 2, 3, 4, 5. So slope of -2/5. Y equals -2/5. X, and I'm going to make this bigger here in a second. Y-intercept of +1. The green line also had a negative slope, going down 3 to the right 1. Y-intercept 4. Yes. So this is good practice, so you should be doing it. So make sure you have those 3 equations written down. It's going to help us answer these next ones. Then in the next questions, it's talking about something, which line is parallel. Does anyone know what that word means? Parallel. Okay. So if I'm using, they're like right across from each other / I'll give you the formal definition here, but which of these look like they're across from each other or near each other? If we were comparing, so we're looking for which colored line is parallel to line A. So line A is this one. Which one looks like it's right across from this one? The brown one. So that would be your answer to number 1, brown. We said which one is parallel to line B. Line B is this line right here. So the red one looks like it's right across from it. And then by default, the last one would be green. Taking the informal definition of it looks like it's right across from each other. Keep that in mind. I want you to work with the people around you to answer the questions on the next page. And I'll give you some time to go through that, then we'll come back and talk about it, and then we'll move on. So on this next page, what do you notice about the slopes? What do you notice about the y-intercepts? Compare the equations. And the equations we're talking about are line A and the brown line, line B and the red line, line C and the green line. You're comparing those two to answer the following questions. So do that, and I'll give you some time talking to your table partners. For number 4, what do we notice about the slopes of each pair of lines?
The rise is the same for each equation.
Just the rise.
Yeah. Well, yeah.
So you're saying just the y value and the slope is the same for each equation?
Right.
So just the y value is the same?
No, not like the whole thing, like just the rise, like from the rise of the line.
So the rise is just your y value of your slope. But rise over run, the whole thing is the same, yes. So if you say rise over run or the slopes are the same. So if you had something along the lines of the slopes are the same, you found the correct thing. If you had anything else, erase it. What did you notice about the y-intercepts of each pair?
The brown line, the y-intercept is the same, but the blue line is different.
I don't think that was. I don't know why I put positive. That should definitely be negative. Okay. That was my fault.
Oh.
Okay, so then
They're all different.
they're all different. So when we talk about parallel lines, yes, we use the definition that they look like they're close to each other or, along, what did you say earlier? About parallel lines, what did you say?
They're like,
Next to each other or something like that. But specifically, they have the same slope and different y-intercepts. So we could combine those two things to say about parallel lines in general. Parallel lines have the same slope. And different y-intercepts. So then it's asking, are these two equations parallel to each other?
yeah,
Yes. How do we know that?
the slopes the same.
And
There's a different line and stuff.
correct. So both things have to apply in order for it to be parallel. The slopes are the same, the y-intercepts are different, these are parallel. What about these two?
No,
How do we know they are not parallel?
because the slope is different.
And that right there alone is enough to say these are not parallel. So now I need 3 different people to give me an equation, a random one, that would be parallel to this. To number 13. So it would have to be parallel, so the slope has to be the same.
This is,
Y equals 2x.
Y equals 2x plus 4. That's 1. Give me another one. Someone else.
y equals 2x minus 7.
Sure. One more.
Y is 2x minus 5.
Sure. All of those would be parallel. You could really put whatever y-intercept you want as long as it is not minus 3. Now give me 3 different people, 3 lines that are not parallel. So some equation that would not be parallel to this one. You can choose or I can volunteer you. Sure. Y equals 4x minus 2. That would not be parallel. This will come out the same. 2 more. Okay, really.
Y equals 3x minus 2.
Sure. Y equals 3x minus 2. The slope is not the same. One more person.
Y equals 6x.
You ready?
Y equals 7x minus 2.
Sure. So as long as it has a different slope, it is not parallel. Now we're going to do the same process for a different investigation. So now you need your other 3 colors. Graph those points, count your slope, continue the line, and make those lines. Great. Your line should look something like this. Your blue line should look something like this with a negative slope. Purple should look something like this with a positive slope. And then orange line something like this with also a positive slope. And then if you didn't write this down or didn't get to this, go ahead and write this down for the equations of the following lines. The equation of our blue line, if you did this by slopes, we are going down 3 to the right 2, and our y-intercept is at positive 2. So y equals negative 3/2 x plus 2. Our purple line is going up 1 over 3, and our y-intercept is at 7. So 1/3 x plus 7. And then our orange line is going up 5 over 2. And the y-intercept is at -10. So y equals 5 over 2x minus 10. So we talked about parallel, they're next to each other, they have the same slope, different y-intercept. Does anyone know what the word perpendicular means? Okay, so they look like that. They cross like that. So if I were to ask which line is perpendicular to line A. Sorry, this is line A? Yeah, okay. Line A, which line goes like that? Orange. So I could like make that and the orange would do that. So your orange, I didn't do this last time but I wrote it late. The next part asks for the equations of the 2 lines, so you can write your orange and your line A equation. I'll make this bigger here. And then line B, which one goes like this? So line B, blue. You can write the equation of your line B and your blue line. Right, And then by default, the last one is purple. And you can write those equations as well. Kind of sloppy, but that says y equals 5 half x minus 10, negative 2 is x plus 1. This is a 2. Right? Just like the last set, I want you to use these equations to answer the next questions on the next page. Talk to each other. It will not be exactly what you wrote down before, but you will notice something about the slopes and y-intercept. Alright, what did we find about the slopes?
All the flips.
So when you say flip, what does that mean?
Like instead of the
Like the
line.
front.
Yeah.
Is that the only thing that changed? Like,
The y-intercepts also.
so just about the slopes.
Oh, just about the slopes. No, that's it.
Scott.
I also drew
So 2 things happened. They flipped, sure. The slopes flipped. And they were either positive or negative, vice versa. I remember not. Each had a positive and negative. Right, and then what about the y-intercepts? What did you find about them? They're different, but they also go in the same. It didn't matter. So if we were to make a general statement, we would say that perpendicular lines have to have a slope that's flipped. One has to be positive, one has to be negative, and the y-intercepts can be same or different. Trying to make that shorter. Perpendicular lines have flipped slopes where one is positive and one is negative. And the y-intercepts don't matter. So perpendicular lines have flipped slopes where one is positive and the other is negative, and y-intercepts don't matter. They can be the same, they can be different, it doesn't matter. So for number 1, are these perpendicular?
No.
No, how do we know that?
The line is
The slope is exactly the same, which means these would be what?
the
Parallel. Are these perpendicular?
Yeah.
And how do we know that?
One slope is short.
The slope is flipped and
It's never.
one is negative, one is positive, the y-intercept doesn't matter. So I need 3 different people who didn't give one before to give me an example of a perpendicular line to this one. Y equals 2x minus 3. No one gives one, I will call it. So you gave one earlier. One different. Minus 5. Now would it be positive 1/2? No. So negative 1/2 x, what was the rest of that?
Plus 5.
Okay. So this would be perpendicular to this. The slopes are flipped. One is negative, the y-intercept doesn't matter. I need 2 more. That did not give me one. You gave me one earlier. You also gave me one earlier. Going once. Going twice. And then give me a perpendicular line.
I don't know.
So the slope is going to be this.
It's a negative, bro.
Unless you're M and you're not speaking. Say it again. I need one other person.
I think Aiden said he wants to go. I can do it.
Going once. Go ahead, Jacob.
Y equals negative 1 over 2x plus 4.
Beautiful. Now I need 3 other people to give me lines that are not perpendicular. Going once. Going twice. Go ahead, Dominic.
Y equals 3x minus 2.
Sure. These could literally be whatever you want. 2 more people. Going once. Going twice. You may have to do this sometimes because some of you have already gone. First.
Y equals x plus 5.
Sure. One more from someone who has not gone.
Y equals 4x plus 3
4x, what was that last part?
plus 3.
So as long as you know these are not perpendicular to this, you can write whatever you want. Alright. You don't have a whole lot of time, but I need everyone to stand up. Everyone, okay, everyone. I need you to walk 5 steps in any direction.